Hello everyone, am I audible?
Yes, sir.
Okay, so let us start. Okay, I'll share my screen. So last day, what we have done, we have seen how to write basic classes and how to create the objects of the class. So today we'll go further with the object orientation, like we'll learn how to do the inheritance, how to achieve polymorphism and other properties of object orientations, right? So I think my screen is visible, right, to you?
Yes.
Okay, okay. Okay, so before I go in any detail, so let us try to understand what are the access modifiers we have in Java. Okay. So the access modifiers can be used for a class or for the members of a class, right? So if I say what are the members of a class, the members could be instance variables. The members can be instance variables, or they can be methods, right? Up to this, it's okay. So we can have access modifier for the classes. We can also have it for the members of the classes. So what kind of members we can have for a class? It can be instance variable, which defines the properties of a object, and there can be a number of methods which basically define the functionality of the objects. Now a class can be either a public class or it can be of type default. Means I don't write anything. If I don't write anything explicitly, what is my access specifier is, access modifier is, so it's by default takes a default, right? Okay. Now I'll go further what we can have for the members, right? So for the members, it could be of four types. It could be public, then it could be protected, it could be default, and it can be what? It can be private. Up to this, it's okay. What are the names? What are for the classes and what are for the instance variables? Is it okay?
Yes,
Yes.
sir.
Yes, sir.
Okay. Now try to understand. So we'll discuss a topic called as a package, although we have this topic in more detail afterwards. Uh, so what is a package in Java? Like in other programming languages, we have seen the libraries, right? So you can have a library within which will have predefined classes, predefined modules, right? So similarly in Java, we are having packages. So packages can have sub packages and predefined classes, right? So you can have predefined classes grouped together within a package, but package can also have a sub package that also have some classes, right? Predefined classes. It's having a hierarchical structure. So for the time being, let us consider a package is nothing but collection of some classes, right? So let us define two packages. So I define two packages. Say this is the package. Let us name it as a P1. I have another package. Let us name it as a P2. Right. So I have two packages. The inside the packages, I have several classes defined, right? So suppose within P1, within P1, let us have a class which is named as a C1. I have another class which is named as a C2. I have another class named as a C3. I have also a class inside P2 that's called as a C4. I also have a class here called as a C5. So there are 5 classes. Now they are basically distributed into 2 packages. C1, C2, C3 are belongs to a package. You can consider it as a folder or a directory within which I have kept the class files C1, C2, C3, and P2 is another folder inside which I have kept the files, the class files C2, C4 and C5. Up to this, is it clear? This distribution of the classes?
Yes, sir.
Okay. So let me have certain relationship between the classes. So I have a relationship between these 2 classes. I represent it with a arrow like this. And also I have a relationship between these 2 classes. We call them as a relation of inheritance. Inheritance, right? So inheritance, which basically implies a relationship between 2 classes, right? So I'll go into more details what is this relationship is about, because I'll do the coding for it. But for the now, for the time being, my objective is to explain this thing. Okay. Now, first thing about the classes, suppose from C1, so I'm on the C1 class, means I have written my main on the C1, and I try to access C2 or C3 class. Means I want to create an object of class C2, C3. I can always do it because it is within my same package, right? I can always do it because C1, C2 and C3 are within my own package. Whenever I'm trying it from the scope of C1 class, okay? But the moment I'm sitting over here, trying to access C4, what will happen? I'm trying to access C4 now. Now, what is the access modifier for C4? That plays an important role. So whenever the C4 is defined as a public class, if C4 is defined as a public class, then C1 can create an object of C4. But in case this C4 is defined without anything, means it is having a default scope, then I cannot create an object of C4. So there is a scoping, we called a scoping. So I say whenever I want to access a class from C1, so I am sitting on the C1, I want to access other class, I want to create an object, right? So suppose I have created an employee class over here. This is the employee class, this is some salary class, this is some a manager class, this is some HR class, right? Now, whenever C1 is trying to create object of different classes, if the classes belongs to the same package, the object creation is or access is always possible. But if the classes belongs to a different package, the class has to be declared as a public class. The class has to be defined as a public class, then only you can create an object. Otherwise, if I don't define it as a public, by default, the scope is within the package. By default, the scope is within the package. So that's why if the class is defined in a different package, I cannot directly create an object if it is not a public. So that means if you have a default, that means your scope is within the package. The scope is within the package, whereas public means it is anywhere. The class can be anywhere, but still I am able to create an object. Up to this, is it okay? When I should create a public class and when I should not define it as anything, right? Does it make sense?
Sure. So public basically means anywhere means what? Means inside the program or package, or we can have separate packages and there also we
Anywhere,
can access.
anywhere. Yeah, anywhere means anywhere. We can have
Okay.
across the package in the same file. Yeah.
Okay.
So mainly like the boundary is the packages. So by default, my accessibility is within the package. So that's why if the scope is default, I can access any class which is within the same package. But if I want to access beyond my package, the class has to be defined as a public class. Does it make sense?
Yes, sir.
Okay. Just to make a caution over here, you have another kind of scope also private, but private. But that is not for normal classes. It is only applicable to some kind of class called as an inner class. We'll discuss it later. Okay. Now we have discussed about the uh, we have discussed about the what do you say about the accessibility of the classes. Now think about the members. Suppose I have some data members within C1. Say this is a data member. I name it as a A. I have a data member B, C, D, E, or B, C, D, A, B, C, D. So they can be a data member, means instance variable or a method. I do not mind, right? But what I have, I say A is defined as a public, B is defined as a protected, C is defined with nothing, mean it is default, and D is defined with a private. Okay, understandable up to this?
So ABCD are object of class
No,
one.
no, not object. They are the instance variable or methods. They are the members of class C1. Like I'm having an employee which is having a data members called salary, employee ID, name, right?
Okay, sir.
So that can have different scopes, right? Access specifiers. So you can have a public, A is defined as a public, B is as a protected, C is as a default, D is as a private. Now, whenever you are on the same class and you want to access ABCD because you want to access ABCD, so you will be able to get access to everything. So your accessibility will be within the class everything ABCD. And so whenever you're sitting inside the same class and you want to access the members of the class, which can be methods or which can be instance variable. So we do not bother what is the access modifier. We can access everything, right? But suppose I'm sitting, not sitting on the same class. Suppose I'm sitting on a C2. I'm sitting over here. Now what I can access? Now if I'm on a different class, what I can access, the question is, right? Now A is a public. So public, I say I can access anywhere, right? That means if it is a different class, I can access it. B means protected. The accessibility will happen through inheritance. Through inheritance. So since C, this C2 is inheriting C1, I told this is an inheritance relationship, these arrows. So I can also access B, right? Now what is C? C means default, means within the package, within the package. So this class also within the package I can access, but what I cannot access, the private having a scope within the same class. So whenever I define any members as a private, that is accessible only within the C1, not outside that. So that's why what C2 can access of C1, it can access A because it is public, accessible from anywhere. B because it is protected, it is accessible through inheritance, plus also package, right? And C because it is default. Default means the scope is package. Since C1 and C2 belongs to the same package, I can access it. So just I'll put it over here. So protected is inheritance plus package. So it also gives the package scope also. But private means within the same class. So most restricted access. So if I want a particular instance variable or method could be only visible within the same class, then I'll make it private. That is most secure, right? And if I want only the classes inside my package will be able to access the method or the variable, I'll make it as a package. If I want the particular variable can be accessed if it is on the same package or if it is inherited, then I'll make it as a protected. But if I want, there is no security in the sense I want my variable to be accessible anywhere, I'll make it as a public. Okay. Now what C can see? C3. Anyone? A, can it see?
A can.
A can. B?
B, no. Inheritance.
Yes, it is inheritance plus package also, right?
Okay, okay, okay. Plus package, yes.
He
Package
can
also.
be seen.
C? Yeah, C also. But D? No.
No.
D, no.
Okay. C for what it can see?
A, B,
A, B. C,
C.
no. No.
Oh, okay,
It's the
yeah.
same package.
Yeah, same package.
D
Yes,
is
yes.
private. So this
See,
protected,
no.
no, this is a or. Okay. It is not and. It
Okay,
can
okay,
be
okay.
inheritance or package, but it is restricted to only package.
Okay.
C5,
A.
only A.
Only A. Yes.
Okay. Now, uh, during the teaching, you have learned two terms coming every time, this encapsulation and abstractions, right? So the easiest way how we achieve it in object orientation and what it is, you can think about. So everyone try to look into a C1. So each of us trying to look into C1, but our position is different, right? So maybe I am on inside the C1, you are inside C2, you are inside C3, someone inside C4, someone inside C5. Being C1 the same object, each of us will have a different view of C1 because we are basically at different position. Are you understanding what I am trying to say?
Yes, sir.
So if you're sitting on C2, we'll get a view of C1. If you're sitting into C3, you'll get a view of C1. If you're sitting into C4, you'll get a different view of C1, right? So if you're into C1 itself, you know there are four things inside C1. But if you're on C5, you know that C1 having only one thing, right? So this access modifiers do what? It provides a encapsulation. It hides the data or information, not data, I should say. It hides the information within the class. And for that reason, depends on which is your scope, you get a different view out of it, right? So I'm just giving a simple example, analogy, just an analogy. Suppose whenever you're coming to my class, whenever you're seeing me, I'm a teacher. My view is a teacher, but your view to me, you are a student. But suppose you also do a private tuition. Whenever your student looking at you, you're not a student that time, you becomes a teacher, right? So your view is changing. Why this view is changing? Because you do not reveal every information to everyone. You encapsulate your informations, right? So encapsulate means it's a technique how I'll hide my data. But after hiding, what is the view extracted out of it? That is basically the abstraction. That is basically the abstraction. Now you can say what I can, okay, I'll give one another example. So I read it in a book, I think it's written by Scott Mayer. So he told like abstractions are the VIPs within the security of encapsulation, right? So uh, what exactly it is, suppose tomorrow any of us go to an election and wins the election, he'll become a VIP, right? And he'll get a security, right? He'll be encirculated within a security. So the point of time he'll get a security, basically he'll present a different view out of it. So everybody outside of your scope, everybody will think you are a VIP person, right? So putting a security belt outside of your range, like across around you, it's basically I'm keeping you encapsulated, right? I'm not revealing every information, so that's giving a different view of it. Since we are becoming a VIP. So the idea is not the security here. Rather, I don't want my user to be overloaded with lot of information, right? So suppose you go to a bank, you ask the manager, I want to open a account, right? So will he say I'm having 10 types of account, you can do this, that. Rather, he'll find out what is suitable for me. Accordingly, he will suggest one thing so that my things will be focused. I don't will be information really overloaded, right? So the same idea over here. I want to give exactly the thing people want. I don't want to give anything extra to the people, right? My viewer. So this is the idea I want to achieve through this access modifiers. But uh, for programming critically, you got it right. When I should go for what? So I'll try to do this. I'll show it programmatically. But for the timing, something I cannot do. I cannot show you the package. Package. I think it is there in week 6 or something, 6 or 7. I cannot remember. So then I'll do it. But I can show you this public, protected, and private how they works. Okay. You can see this, right?
Yes, sir.
Okay. So for the time being, I may not keep it as a public, right? If it is there public also, I don't have any problem. But for the time being, let us have a employee class. Last day also we have done it. So last day what we have done it, if you can remember, we have created the instance variable as an employee ID, and we had a name of the employee, right?
Yes.
Now, if I don't specify anything, what will be their access type is? Access specifier is access
Default
mod. This will be default. They can be accessed across the
package
across the
within the
path.
package.
So for the timing, let us have it as a public, which is not a good practice. I don't want everybody to access my internal details. So hiding the internal details of a class is called as a encapsulation. The idea is I don't want to show everything to everyone. I want to give just specific information what he requires, right? So if it is a public for the timing, which is not a good practice, I want to keep my method also as a public. I want to keep it as a show, right? And I'll have a system dot out dot println. Um, I'll say EID plus EID plus plus name, right? So everything is a public, right? So what I can do, please interrupt me like whenever you're not getting, because I cannot see your hand raise or anything because I'm on the screen.
Yes, sir. Yes.
I go every time over there, it will like disturb my flow.
Yeah.
I have EID, I can access this directly since this main and employee are two different classes, but EID is a public. So I can access them across the class also. I can initialize it as a, and I can initialize it as a something ABC, and I can call it as a show, right? And if I run this, so I get my output. Okay. Now, what encapsulation says that instance variable should be hidden, the implementation details which are, but interface should be accessible from outside, right? So what are interface? The input output functions, because other classes has to give the input and see the output, right? Otherwise, how they will use it? If I make everything encapsulated, if I make everything private, nobody else will be able to use it. So I have to
Yes.
define certain functions or method which will be public, through which I'll be able to give the input and I'll be able to see the output, right? So like this show method, it is an interface, right? Through which I will be able to see the output. But the moment these internal details, the instance variable, I'll make them private, right? What will happen? This accessibility will stop. So if I run this, so it will give me an error. It say EID has a private access. So in the
Yes.
same class, you are having a show method which can access EID, which can access name, because show is defined within the same class. It do not have any problem. But whenever I'm accessing from the main is in the different class, like, right? So that is creating a problem. So these two are now not accessible, right? So what is my idea now? I have to give user an input interface, right? Through which user will be able to access the ID, right? So again, another example, I read it in a book. Suppose somebody, you're asking me, give me 10 rupees. Will I give my purse to you, or I'll take out 10 rupees and give it to you? Definitely I'll take out the 10 rupees and give it to you. I won't hand over the entire thing to you, right? So the same idea over here. So if you want to access the thing, right, I don't want to make everything public to you. I'll give a specific interface through which you'll be able to access it, right? So I want to access EID. I want to rather initialize the EID. So what I can do, I can create an accessor, right? I want to create a accessor. Um, so professor has named it something, no? Accessor and mutator or something. Can you remember the name?
Accessor and
Yes, sir.
mutators.
And
Mutators.
mutators. Okay, I cannot.
Mutators are those which update the data, and
Mutators.
accessor which
I cannot
erase.
remember the name exactly. It's okay. Okay, so I want to initialize the EID. So I can have a set method to initialize the EID. So I can pass here int I, which will initialize my EID. And I can have another method, void set name, which will initialize my name. Now, good thing about whenever you are calling set EID, you are well aware of only EID can be modified, nothing else. If you are calling the set name, you're very aware of it, only you can modify, that is the name. So that's how, instead of accessing the members, the instance variables directly, what I do, I can call the set name and I can pass my name, and I can also pass my set EID, right? What happened? Oh, sorry. It is a string, right?
Yeah.
Name is a string. So I'm passing a string actually, right? So this has to be also a string. Okay. So these are my input interface. This is my output interface. So rather than show, I can explicitly have different interfaces for accessing the name and accessing the EID. So I can have similarly a get method, right? So get method, because EID is a int, I can have get ID, get EID, right? So I don't want to assign it, just I want to get thing. So whenever I call get EID, I supposed to only get the EID. So give only the thing people want. Don't want to give anything extra. Get name, return name, right? So instead of show, if I have a system dot out dot println and I want to print the EID. So EID, how I'll get, it's e dot get EID plus name e dot get name, right? So these are the accessors. This accessor will get me the ID. This accessor will get me the name. Is it okay?
Yes, sir.
Yes, sir.
Sorry. Okay, so everyone is fine, right?
Yes,
Okay.
sir.
Okay. So
Yes, sir.
I'll go further. Could have been better. No, I save it somewhere because I can share the code afterwards, right? I'll share it somewhere in Discord or somewhere so that you can look into it afterwards. Okay. Now, the practice is you can have an constructor inside your class. Last day also you have discussed, which will initialize the instance variable of a class, right? Of an object. So if I have to create an instance constructor for an employee, I can make it as a public because constructor is supposed to be called from outside, right? Outside of the class, but it is not mandatory again. So this is called a default constructor or no argument constructor, which will initialize with something default thing. Say if I don't specify anything, the ID will be -1 and name will be something called as an unknown, right? But if I'm very specific, like what employee it is, then I can pass the arguments. Say I have I and string n. I can have EID I and name I can have employee equal to new employee. So EID is 10. So this 10 and ABC is going into my parameterized constructor, which is this. So I is getting my 10 and 10 is getting ABCD, which is ABC, which is getting into EID and name, and I'm getting my value back. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now my question is, I can use a constructor to initialize the thing. I can also use this mutators to initialize my variable. Which one I should use and when I should use?
Sir, can you repeat the question?
I'm saying this constructor can initialize your instance variable. This set, the mutators also can initialize your instance variables, right?
Yeah.
So shall I go
Hmm.
for having a constructor or just mutators are okay? And when I should go for a mutator, when I should go for a constructor?
When
Construct.
we want to change a single value like only the EID or only the name, then we should use this mutators. And if we want to initialize, then we should go for constructor.
Initialize means
While
if
creating
I'm
an object,
initializing
applying
EID also, it's initializing, right?
no, like when creating an object, during that time we can give the name and EID.
When I'm asking why I should give it, I can do it afterwards also using a mutator, right?
Yeah, we can.
So why I need constructor thing? Okay, one
Encapsulation,
point.
if we want to follow.
Yeah.
If we want to follow encapsulation so that we can't directly access someone can't directly access the variables from outside the
Since I'm making it private, it's encapsulated, right? I'm accessing them through an interface in both the cases.
Hmm.
Mutators are also interfaces. Constructor is a kind of interfaces again.
Hmm.
Okay, so just write one thing in bold that throughout the lifetime of an object, constructor only can be called once, right? You
Hmm.
cannot call constructor several times in a life of an object. It can be called only once, right? So whenever you want an object to be initialized only once, right, then it is always a constructor. But if you want your instance variable to be changed afterwards, then it is mutator. Constructor is always secure practice because just think about a stack, right? In stack, your top has to be always on the minus one, right? So that is always better to do using a constructor, because if you give a mutator and your user changes the, you call the stack initialization at some time else and make the top to point to something, right? See, enter stack will go off. So you don't want the people to call the uh, stack instance variable explicitly. So it's always better you have a constructor and through which you will initialize it. But in case afterwards you're supposed to change the values, right? Then you can go for the mutator. Otherwise, always be good practice it's to use the constructor only. But again, I'm saying in case if you want to change the value after creation, right? Then you can have the mutator. So mutator give your users a scope. They can change the instance variable anytime, right? So that may be restricted. You want to restrict that. So you want to initialize the things and the state of the objects will be changed automatically, right?
Yes.
Everyone got it right?
Yeah.
Yes, sir.
Yes, sir.
So mutator accesses are done. You got some idea about the interfaces and instance variables. And again, the things, good thing about having an encapsulation over here, okay, we can change the implementation details, the instance variable any point of time, keeping the interfaces, the methods, the name of the methods, these are the same, right? These are the interfaces. So if you just keep it as a get EID, right, and change the internal code, when you change this EID variable, you give some calculation, then return it. My user won't mind because user know if I get call the get EID, I supposed to get my result, right? So the idea is the implementation can be changed in a point of time, but you're not going to change the interface. I'm giving an example, maybe not be it's everybody will understand. The people with PDSA course will understand it. Suppose I'll go for a different example also, analogy also. Let us have it first. Suppose I want to create a linked list, right? Oh, sorry, I want to create a uh, suppose I want to create a stack, right? Oh, sorry, queue. Now a queue can be created with the array. A queue can be created with a linked list also, right? Now, Suppose you are having the interfaces like insert front, insert end, remove front, remove end kind of interfaces. So user know how to call them. Now internally, if you are implementing with an arrays, after some time you are changing with the linked list, that that is not botheration of your user, because user only has to access it with the particular interface name, right? As long as those interfaces remains the same, my user is fine. So let us have an analogy. Suppose you go to a bank ATM. Now you're putting a card, dialing the pin and drawing the money, right? Now you insert a different bank card into the same interface and drawing the money in the same method, right? You're dialing the pin, doing the same, pressing the button. So everything is same. So you're using the same interface. But the codes of different bank, the calculation of interest may be different for a different bank, right? But you do not bother how these internal details are and how they'll be changed, because as soon as you find the same interface to access it, right?
Yes, sir.
More generalized example, you have a switch right in front of you. So the switches are for light, switches are for the fan. As soon as the switches will be on off in the same way, you do not bother how to operate it, because the implementation is with whom it is working with fan or light, they have a different kind of working principle, working details, right? Internal details. But being the interface being same, the user is always happy. So if I have a different kind of switch for different devices, I won't be so happy, because I need to remember the different things, right? If I'm said okay, for every bank I will have different kind of ATM and different process to draw my money, I'm not happy, right? I'll be rather happy to use the similar interface every time. Let the internal details, the implementation details change internally. I don't bother. Okay, I'll go for next thing. Next, I want to go for inheritance. Okay. Okay, so I want to remove a number of things over here. So I think I have copied it. I'll make another copy of it into my notepad. Please remind me tomorrow morning. I'll put it on the discourse. Okay. You can just write on the discourse. Please share it. I'll put it.
Okay, sir.
Okay. Okay. Now I say the technical definition of an inheritance in Java is the old class is extended to a new class. You're already having a class. You want to extend it into a new class. What is that? So suppose I want to implement uh, uh, employee management system inside my organization. So I'm finding I have to create two classes, a employee class and a manager class. Now, this is important. I was telling about easy. So employee is a manager, right? Every employee is a manager. So that means manager will share the same properties of an employee, right? Manager will share the same properties and behavior of an employee. So now, if I already have an employee class, why I should write again a manager class from the scratch? I'll try to reuse what is already there in the employee. I'll just write what is extra in the manager. Am I clear?
Yes, sir.
Yes, sir.
The point is, I don't want to write my class from the scratch. I want to reuse my existing class. I want to extend it. So I have to create an employee class. I have created. I have to also create a manager class now. And I'm seeing every manager is an employee, right? So what an employee will have, manager will definitely have it. But reverse may not be true. Manager can have some extra functionality or properties, right? So since I have an employee, why I will create a manager class from the scratch rather than reuse whatever I'm having in the employee, add whatever I want to do extra, right? So that's how I gone for creating a manager class, right? I say extends. So I want to extend the employee class, what I already have. So that means, so for private, you cannot do the extend in this way. So for the thing, I'm making them as a protected. So it's always good to have a protected member whenever it is a, I'll make it private also. I'll show it how to do it with. But for the timing, make it protected, because if you just go to this figure, if you just look at it as a protected, B is a protected. So protected can be accessed through inheritance only, not by anybody else, right? So that's how, since this is inheritance, I'll give a protected. So protected means this thing will be automatically, implicitly get copied into a manager class.
So, sir,
Got it?
can't we access it in employee class as well? The protected
That's
way.
by default, right?
Hmm?
That's by default, right?
Hmm.
I can access everything within the same class.
Hmm.
That's not a problem. But different class, if I say, I don't want everyone to access it, but I want it to be seen by inherited classes.
Okay.
Then how I'll do that? I'll do it through inheritance, right? That's the, sorry, I'll do it through protected, because
Yes, sir.
protected can only be accessed within the same class or through the inherited class. So inherited classes are called as child classes, right? And from where I'm inheriting, that's the parent. So in this case, which is parent? Employee is a parent, manager is a child. It's okay.
Yes, sir.
It's
Yes, sir.
something like my father having a brown eyes, I'll have a brown, I'll inherit the same thing, right? The same thing. So I don't have to explicitly define it, I'll get it automatically, something like that. So the manager already have this EID and name, so I have to just define what is extra I have. So say every employee will have a particular department information, right? So that is extra. So now, whenever from employee you're going towards the manager, it's called a specialization, right? You're going for a specific. Whenever manager to employee, you're going for a generalization. You're going for a generalization, because you can have other classes also, like I'll have a accountant, which can also extend, because uh, an accountant is also an employee, but maybe he will have certain other properties, right? So accountant may be having some, I don't know what specific thing it can have, maybe some credential, right? So that's the extra thing it is having. So manager and accountant both are employees, right? So accountant is a employee. So this is a term again I repeat, because how I'll understand, I can have a relation of inheritance between two classes. I need to look for is a, right? So I said car is a vehicle. That means if I have a vehicle class, I can inherit a car class out of it, right? If I say football is a ball, right? That means I can inherit a football from a ball. If I say square is a rectangle, so if I have a rectangle, a specific type of rectangle is a square. So from parent to child, it is a specialization, right? So employee, I make it more specific. It is a specifically manager employee. If I make it more specific, it is a accountant employee. Then it is called a specialization from parent to child. But whenever I say I moves towards the parent, then I'm generalizing the thing. I say manager also is an employee, accountant is an employee, right? So actually inheritance is an generalization. So you can see the arrows are towards the parent. And so I'm doing the generalization over there. So this arrows always goes towards the parent. So specialization and generalization, these two terms are clear to you?
Yes, sir.
Yes.
Yes, sir.
Okay. So let us have then more thing. So suppose here I'll have, so I'm not going to have much thing over here. So public show method. So I'll have system.out.println. Uh, I may have to take an extra class next week because I'm a bit lagging. Is it okay?
Yes, sir.
Because I want
Yes.
to do some more program. So whenever I write a show within the manager, I can also show the department. Although I repeat, it's not a good code. I'll show you what is the good code. I can also have a show method for accountant. Credentials, something. And I can have constructors because since I want to create and employee, manager, etc. So let us directly go for a parameterized constructor. Again, I'm saying I'm not writing a good code over here. I'll make it good code actually. So that you can understand step by step if I do what and what is the effect. And name is n. So this is a constructor for my employee. I want to have a constructor for manager, so which can have int I, string name, and string t. I'll have eid equal to I. Please mention if I'm omitting something. I'm just typing them quickly. If I miss something, please let me know. I can have public accountant. Credential C. Okay. Okay, so I'll just delete everything from this. So I want to create a manager, right? Suppose I want to create a manager. I'll have a m equal to new manager. So what a manager will have, I can have a employee ID, a name, ABCD, and a department, I say IT. And I can have m dot show. Running my code. I haven't written void, right?
Yeah.
We're supposed to catch this. Okay. So method will have a return type, but constructor do not need a return type, right?
Yes.
Okay.
So also the system.out.println, you miss the S over there.
Oh, I have copied this, right? Okay. Everywhere it's gone the same. Public manager. What is this? Constructor employee. Oh my God. EM. Constructor employee. Class employee. Okay. Okay. Sorry. I'll mention this. Huh? This is a typical problem. It's logical. It's my mistake only. I'll explain it why this problem comes. I thought I'll be explaining it later. Anyhow, okay. So I'm creating a M manager. I'm having 10 ABCD ID M dot show. So it goes to the manager class, right? So inside the manager, I'm having the department, but since it is extending employee, so what I'll have in the employee class means these two. It will be combined with this So I'll have this access to EID name department over here, which will be initialized and it will be displayed. So I can access EID name over here because those are protected. If I make them as a private over here, private cannot be inherited, right? The moment I'll make this EID as a private, this will show error. This is not possible. It is showing an error because he is a private, so it is not inherited. Similarly, he is also restricted. I'll get it somewhere. This is also restricted, right? You're getting this here. Sorry, it's going off. Yeah, this EID access also restricted. This is also showing it for this class also. This class also EID got private, right? This is also private. So if I make it private means this EID can be accessed only within this, not outside. So I'm writing this EID inside the manager, so that's not possible. But in case of protected, I can do it because they are accessible through inheritance by the child classes. It's okay?
Yes.
Yes, sir.
Okay. Now come back to another thing. I'll talk about reusability, right? So what about this member? This is a method, right? Show. So along with the instance variable, will it be reused? Yes, it will be reused. So even if I don't write the show within these classes, this show method already is there. So if I just suppress the show, right, and I'll try to run this. So manager do not have a show, right? But I'm calling show. So from where it will get the show? It will get the show from the employee thing. Notable thing, you are not getting this department information because the department information is not there in the employee class show. Is it okay? So show is getting also inherited because it is public. So anything which is other than private will be getting inherited. It's okay?
Yes, sir.
Okay. But what again if I rewrite the show inside my child class? This calls method overriding. Overriding. Overriding means a copy of show is given by my parent to me, but I'm saying I don't want to use it, I'll override it, right? So this is method overriding. So if I'm overriding this, then parent method will be suppressed and my method will be prioritized. So this will get prioritized over this because I'm having a copy of this which is overridden by this, right? So I'm getting my own definition over here, right? Now, this is the job of method dispatcher. Whenever you have a scope to call different version of the same method, which one has to be called? So if I'm calling it against the object of manager, there is two versions. You can call the show from the employee class. You can call the show from the manager class. Which one will be called? The child copy. The child copy. Because child copy is overriding the parent's copy. Is it clear? Remember, for any programming, the local will override the global. So for manager, I'm getting it from my parent. It's not my own. But whenever I define it my own, then I'll use my own, right? It's something like if your father having a house, if you are the sole only child, then you'll get it automatically. But instead of that, you're very capable, means you can have your own house and you can stay over there. So you're overriding it. You're not taking all the parent is giving it to you. Is it okay?
Yes, sir.
Okay, so we learned something called as a method overriding. Now we'll again go for reusability. So I'm talking about since my parent employee already initializing these things, right? This EID and N, why I should again do it, right? But remember, constructors are not inherited, right? Even they're public. But I'm saying what will happen if I don't use it? Okay, let us see. I run the code. So in the manager constructor, I'm just initializing. Let us comment this, otherwise you'll get confused. I'll use it in a different way. Okay. So I call the manager constructor. I'm passing three things, but I'm initializing just one thing. Right? So it's logical. Sorry, it's not logical. I'm having the special thing department here, so I should do a department because department is mine, right? Which I have to do because employee ID and name already my parent has initialized. So I don't want to duplicate this code. So I run it. So I'm getting this department is getting initialized with appropriate thing, and these are all default initialization. Right? That's logical. Correct.
Yes, sir.
Okay. I go to the default constructor of the employee. I do something here. I say employee ID is -1. I'm doing an explicit default initialization. I say if the name is not given, it will be unknown. Now I run this again. So I'm getting the default initialization from my parent. Now remember again, this is, again you can write it down in bold that whenever you call the child constructor, it implicitly called your parent default constructor first. Whenever I'm calling the child constructor, it will always call the parent constructor default constructor first, and that is implicitly. Got it? You got it?
Yes, sir.
Yes, sir.
Because I have more specialization over here. Say manager also, I am having a HR manager. Can I say HR manager also is a manager, right? So I'm having multi levels of hierarchy, multi levels of inheritance. Here also I am having a constructor. I'm having a HR manager constructor. So I have something. I don't bother. I have a system.out.println. I just print HR manager. Just I want to see like what will happen if I call this constructor. Here also I have a default constructor for manager class. It just print a manager. Here also I called it. So I have a system.out.println. Here I print employee. I do a simple thing. I want to create an object of HR manager. Okay, so if I call this HR manager, this call will go here. It's supposed to print the HR manager. But what is happening, just see. It prints first employee, then calls manager, then calls HR manager. Means if I call this, the call goes here, but it do not execute this. Rather, it will be forwarded to the parent here. Again, it do not execute, it forwarded to the parent. It goes here. There is no more parent, but there is a parent. I'll talk to that afterwards. So here it sends, then it prints employee. Then it will come back here, it prints manager. Then it comes here, it prints the HR manager. So again, whenever I call the constructor of a child, it will call the immediate parent constructor. So if the parent is again having a parent, that again will call the parent constructor before calling itself. Up to this, is it clear?
Yes.
Very clear or little bit?
No, sir, clear.
Everyone, right? This is a difficult concept in object orientation. Okay, I hope it is clear. So I'll go back. Okay. So So why I have to create it? Because by default it calls the default constructor of the parent. Okay, it calls the default constructor of the parent. Okay, but I'm not happy because I don't want the default constructor to be called. I want the, if I call this, I want it should call this parameterized constructor, which will specifically initialize my employee ID and name. I do not want this default things to be initialized. I want this 10 and ABCD to go into it, right? So that access to the parent constructor can be done using something called as a super. Super gives you access to the parent constructor. Now I pass n and m, I and n. So this will override the call to your default constructor. So whenever it comes to the manager, it finds there is a super. So it calls the super class. Super class means the parent class. So another terms for a parent and child, super and sub, right? Super class means parent class, subclass means child class. If I'm calling a super, so I'm calling the super class constructor. So I'm passing two arguments. It will call the constructor with two arguments. So it will initialize this EID and name over here, then come back, initialize that department over here. That's done. So I just call it. This is my intended result, right? So again, I repeat, I call the manager. So the call goes here. If I don't have a super, it will call the default constructor from the super class, parent class. But since I have explicitly called to the super class constructor, it finds there are two arguments, means we are going to call the two parameter constructor from the parents. So this makes calls to this two parameter constructor, initialize the EID and name, then come back to the manager, it initialize the department. Done. Happy?
Yes, sir.
So earlier dynamic dispatch was happening, na? Due to which we were
No,
able
diagram
to.
dispatcher specifically for the methods. It's not for the
Okay.
concept. I'll come to that. Yeah. Okay, one more thing. So again, I need code reusability. See, my show over here already displaying the ID and name, but here, why I should do it again? It's not good, right? So can I remove this? Now, if I remove this and run this, it only prints the department because my show or manager show completely overrides the show from the employee. But I have two copies, right? Both the copies exist. There is a copy from manager, there is a copy from employee. But dynamic dispatchers say no, it is the child class which has to be prioritized. So this show is called. But if I want to explicitly call the child version, sorry, parent version means employee's copy. So the parent can be referred by super. Parent can be referred by super. We have already used this is called to the super constructor. Now similarly, you can have super. Now from super, you want to call the show. So super is a reference to your parent class, right? So this super dot show brings the copy of the employee show, right? Which will print this employee ID and name. Then it will print the department. So by default, always the child will override the parent. But if you want to bring out the copy from the parent, so you have to explicitly call to the super, then this will get you the parent's copy.
Sir, I have a question.
Yeah.
In this scenario, manager is extending our employee and HR manager is extending our manager. So according to HRM manager, which is the super class for HR manager? Is it manager or the
Immediate one. Immediate.
Achha,
It is
immediate?
manager. It's again a layered abstraction. Everybody can see its immediate parent only, not beyond that, right? Now, since
Hmm.
managers see the HR managers see the manager automatically see the employee. So HR
Employee.
manager accessing the employee through the manager, not directly. Okay, so you're
So
getting access. So
Can we access the methods inside the employee
that is what I have done now.
for HR manager?
Then I have to do it through the manager. So where is it? If I have again a overridden thing, show, I can have a super dot show. Suppose I have some printing over here also. I'm not writing. This super dot show will call show from the show from the manager class. Then manager class again redirected to the super of it. That will go into the employees show.
Okay.
Right.
And
So
then we
super
can
will
further.
always access the immediate parent. You cannot
Okay.
directly access the parents of parent, means your grandparent, because you
So
are
if
having.
we have not written, suppose if for manager, if we have not
It
written
don't
that
go. It
super,
don't. It don't
so
go.
then it would not go, right?
No, it don't go. You have to explicitly write it.
Okay.
Right. So you can access your immediate parents only. Okay. Up to this, fine.
Yes, sir.
Okay. Now I'll go for a bit of more conceptual thing, which calls a polymorphism. So polymorphism, it's the same interface with different implementation, right? Same interface with a different implementation. So interface means just for the classes, these are the input output functions I told. Just think about a real time thing. I say a method called play, right? You can play a violin. You can also play a football, right? You can also play a cricket,
Yeah.
or also you can play a radio. So the same interface is a play, but implementation wise, it can do different things. Understanding,
Yes, sir.
right? So you're having a switch, but in the switch, you can connect different kind of devices and you can play, right? A similar kind of concept. So we can bring the same thing over here. Okay. So before that, we'll learn uppercasting and downcasting. Okay, which is again a important concept. But our objective will be, so you're not tired, no, with the things. I can continue a bit.
Yes, sir. You can continue.
Yes, sir.
Everybody fine.
Yes, sir. Yes, sir.
So I'll now use some symbolic name. I am not creating a employee or manager. Suppose I have two classes, class A and class B. These two, no, you can write it on the notebook also, because this is bit of theory you need to understand clearly. You can write the program also, because this is a small program, and you can run it bit later, or you can write it on the compiler also, but keep proper comments. Okay. So extends A. So B class is inheriting from A. So I'll have a B is a A. Okay. Now I'm just doing one thing. I'm having a show method, which is having system.out.println, which just show A called. So these are all symbolic kind of methods. This is, we'll say, B called. Okay. So I create an object of A, which is a new A. I create an object of B, which is new B. I want to create object of A dot show. I create object of the B dot show. So what will be my output?
A called, B called.
A called and B called. Because the object is of A, so it will call the implementation of A. The object of B, then it calls the implementation from B. It's straightforward, right? The object type is A, so it calls it from A. Object type of B means it calls it from class B. Right? No doubt. Okay. Now I want to make it a bit complicated. I make object of A, but class is of B. Object of B, reference is of A. So I want to check it. So I say the reference is of type A, object is of type B. Is it possible or not? Now, rule of dynamic dispatcher, please note it down. A reference can refer to its own object or its child object. A reference can refer to its own object or its child object. It never can refer to its parent object. It never can refer to its parent object. Can you repeat what I told? Anyone?
Yes, sir.
Okay. Why that is? Why that is? You read this subtype thing, no? Type and subtype. It creates a lot of confusion. Can you realize this? Can I say what A can do, B can definitely do it, but what B can do, A may not do the same. What A can do, B will definitely do it.
Yes, sir. We can say that.
But B can do something which A may not do. Right? Because B is a superset of A. B is a superset of A because B, suppose extending A, B will get everything from A and it can have something extra also. Understanding, right?
Yes, sir.
B can have everything of A plus something extra. So B is a superset, right, of A in that way. So that means B will have all the capabilities of A, but A may not have all the capabilities of B. So that's why whenever I'm having a A-type handler, right, I'm sure that can get its own functionalities or the B capabilities from B. But if I have B-type handler, I may not get all the capabilities from the A. Again, I say, whenever my handler is of A type, then for A, whatever the capabilities I want, I can achieve it through B also. But if my handler is of B type, whatever the capability I have on the B, that may not be there in A. So that's why if you have a reference of parent type, your object can be of child type also, because child will have definitely those things. But if your reference is of child type, you cannot refer to a parent type because parent may not have that capability. Got it? Why this rule is? Yes or no? Please clarify.
Yes, sir.
Yes, sir.
Okay. 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 So this is possible or not? Can I do this?
Yes, sir.
I can do this because here A is a parent type reference, which is referring to a child type object. So if we just go back here, so I have, this is the hip. So which is have a object of B, which is referred by a reference of A type. So this is, I'm okay. So now, if I called obj.show, from where the show will called, it is from class A or class B?
So from class A.
Do you
So
have implementation of class A? Do you have an implementation of class A? What is available to you? Your
class B.
object is
Class
of
B.
class A, right? So implementation you have for B.
Yes, yes.
You're just a handler. So you're supposed to get it from where? You're supposed to get it from B class, no,
B class.
B object, because B object is actually implemented. A is just a reference, right? So dynamic dispatcher is here important. So you're having two versions again. I'll call it from A, I'll call it from B. So who wins? Whose object is, right? Since the object is of B, I'll call the B's version. Now, why the dynamic dispatcher is dynamic? Here it's a very important thing. See, you'll come to know where it is referring whenever the object actually is created on the memory, and object will actually created on the memory in the runtime, which is dynamic, right? That's why it's called as a dynamic dispatcher, because where exactly your reference will be pointing to, depending on that, it takes the decision from where I'll call the method. That's why it's called as a dynamic method dispatcher. Okay, so implementation to be called from child. Okay, up to this is clear. So now suppose inside B I have public void something extra. This is B extra called. Okay, no doubt, because B can have some more capabilities than A, because B is a specialization of A, right? Now what if I try to call this extra? What will happen? Anyone? You're there, right?
Yes, sir. Yes.
Yes, sir.
Okay, so see, if I try to run this, it gives me a compiler error. Cannot find, right? The important thing, this is an error. The reference gives you capability. Object gives you implementation. So reference gives you the capability. So the reference type will tell you what are the methods you can call, right? What are the things you can call? So the things are there in the scope of A, those are the things you can call. So within the scope of A, only the show method is there. So that is what you can call. But from show, where I'll get the implementation, I'll get the implementation from the child, right? Now, instead of doing this, if reference is of child type, means if I have a object of B, which is referring to a object of B. So my reference is of type B, object of also type B, and I have this show. So B having a capability to call show, because show is defined within the scope of B, and object B dot extra. Now, do I have the capability, since the reference of type of B, extra is defined within the B. So I have the capability also, I have the implementation also. So I can call both. But the previous one, if I go like this, for this one, I have the capability for show. I'm also having implementation of show. From where I'll get the implementation for the B, because object is of B. But for this, I have the implementation from B. But the thing is, I don't have a capability because my reference is from A. So A do not define any extra thing, extra method, right? So the left hand side, the reference will define what you can call. The right hand side, the method call will define from where you have to call it. The left hand side you will say what you can call. This will say from where you will call. Again I say, we hear. This will say what you can call. This will say from where you will call. This will say what you can call. This will say from where you will call. Is it okay, everyone?
Yes, sir.
The reference type will tell you the capability. The object type will tell you about the implementation. That's all. Okay. Now, whenever our reference wants to refer to a child type, it calls a upper casting. Why it's a upper casting? B is of a child class, which is coming into a parent class, which is casted to a, so B type is casted to a type, right? So child is moving to a parents in the hierarchy are moving upwards. In the hierarchy are moving child to parent. So it's a upper casting, right? So upper casting is always allowed and it is implicit. It happens automatically. Now what about the down casting? If you have B, object of B, new A. So you are trying to create an object of parent type, right? Which is referred to the object of child type. Is it legal by your rule of dynamic method dispatcher?
No.
A reference can point to its own type or its child type. It never can point to the parent type. So if you try to run this, it's straightforward compiler error. So for compiler, it's a downcasting error. Downcasting is always explicit. Downcasting is explicit. You have to force it. So your compiler do not allow it implicitly. So how you can do it explicitly? I say forcefully typecast it. So this is a casting operator, typecasting operator, right? So
Yes.
I say create an object, convert into a B type. So I do an explicit casting. I force it. Okay. So it basically give you a runtime error. It's a class exception because now dynamic method dispatcher is fails because whenever it's trying to point, it is finding the object is a child type object, right? So this is not possible because restricted. You know why it is. But I can basically achieve a downcasting in an indirect way. How I can do this? Let me think it. How I'll show. Uh, okay. Just look into this line. First line is a upcasting or downcasting.
Sir, first line is 1 second.
Child to parent or parent to child?
It's a parent to child. So
Right.
it's
Right hand
casting.
side. Right hand side is
Child.
child is going into parent or parent is going into child. Assignment operator, right to left, right? A child is getting assigned to a parent, right?
Yes, sir.
Child will become parent, right?
Yes, sir.
The right hand side will go into the left hand side in the assignment, right? So child is getting casted to a parent. That means it is a upper casting.
Upper casting.
Upper casting is implicit, always allowed, right? This is
Object B to object A. This is downcasting.
the right side is a parent type. Left side is a child type. So parent is converted into a child. So this is a downcasting. So downcasting should be explicit. So I should forcefully cast it. right?
Yeah.
So compilation wise, it's valid. Now question is, if I say obj.b.show, what should be my output? It is from A or B.
It will be from B.
Why?
It will be from A because B is.
Dynamic dispatch.
Did I created any A object? Do I have an object of A in these three lines?
Yeah, object type of object is
Type is
A.
fine, but did I created any A
No,
object?
no, no.
No, right? So yeah, it's bit confusing, and intentionally it's made confusing. So I have a reference A, first line, okay, which is pointing out to a B object. So it is something like this. Now what I have, object of B pointing to the same thing where object of A is pointing. That means we'll have object of B pointing to the, and this is why the dynamic dispatcher allowing it, even it is a downcasting, because this is a B type reference and pointing to a B type object only. So it is allowed, right? Both the cases are allowed. So last time this was not allowed because here the object type was a parent type and reference type was a child type. That is not allowed. But here indirectly B is making point to object of B only, which is allowed. So if I can call with the B, call with the A, I don't have any problem. It calls it from A, but see here, important thing here. So if I have an interface, if I have a reference of A, I can call show, it will work. But if I call extra, it won't work because the object a reference do not have the capability for calling extra. It is not defined, right? But if I use the reference of B, both are pointing to the same thing. Object of B, I'll have a show. Object of B, I'll have extra. Now I'll be able to do that because I have the capability call both the methods because both are defined in my scope, right? So these two terms, capabilities and implementation, is very important in this context. Okay. Okay.
Yes.
Yes, sir.
So the last program, I'll have a polymorphic interface. Okay. Okay. So I want to use an inheritance. So rectangle is a geometrical shape, cube is a geometrical shape, a triangle is a geometrical shape. So we have a class geo shape, geometrical shape, I meant to say. Uh, that will have, that can be inherited into all other classes like rectangle, rectangle, circle, then class triangle, shape. Say the parent gives the capability, right? So suppose I mean to say every geo shape will have a way to define the area, right? So I give the capability, so all the geometrical shape will be able to show some area. But whenever it is not specific, which kind of shape it is, I cannot be implemented. So I say cannot be implemented. Now this method can be overridden by all, but whenever I'm on a specific shape, I know how to implement this. So I'm not writing the formula, but I want to show you. So I say area of a rectangle. So this is the implementation for rectangle. I say here area of circle. I'll have area of triangle. This is my main class. I'll have my public static void main. Okay. I'll have a geo shape G. Right. So I have a reference. This is just a reference. Now, if I say G equal to new geo shape, it is pointing to the same type. So now if I call G dot area, so which implementation it should call? It should show you cannot be implemented. Now, if the same G, it's a reference, it can refer to its child type also. I say it is new of rectangle. Now, geo shape type reference pointing to a rectangle object, which is possible because it's a upper casting. Now, if I say geo area, G dot area, now since the object is of type rectangle, it calls the implementation from the rectangle. It will show area of rectangle. Now G equal to new circle. If I say G dot area, now since the object is now of circle type, it do the things. Similarly, G equal to new triangle. I can have this G dot area. Now, why it is polymorphic? Because if you look at the interface, this is an identical call. These are all identical call, but implementation wise they're different because each time the implementation they're getting for the from the different child classes, different classes, right? So the same interface with different implementation, because implementation can change, interface remains the same. Now implementation depends on the right side, what kind of object you have. You can have more sophisticated implementation for it. This is more understandable, comprehensive, right? I make it more stylish rather. I take an array. So this is, I'm defining array of 4 references, right? So how I say it's a references? G is a reference which points to an array which will hold again 4 references. These are not again objects. These are holding references. Now G0 is of type geoshape, but it points to a geoshape object. Now G1, which is of top geoshape, it points to a rectangle object. G2, which is a circle object. G3, which is points to a triangle object.
Triangle. Sir, are we calling constructor here?
It's a default constructor, right?
Mm-hmm.
If I don't even write it, it's okay, right? Okay, so int I equal to 0, I less than G dot length.
It will be small, yes.
Huh?
No, it's fine.
No, I'm just thinking it will be bracket or not. And I have to give the parenthesis or not. I think for
String have those, no?
string has the parenthesis, yeah. So see, so left hand side, these are all references of geotype. Since it is pointing to a different object as the index change, It is calling different implementation every time. So this is pure polymorphic implementation. Okay, that's enough for today. Next day we'll move into this abstract class interfaces, etc. Okay, so
Sir, this was week 3 content, right?
this is week 3.
I think week 4 also released today.
Yeah, I know that. I'll
Hmm.
do that.
So next session we will be covering week 4.
Yeah, I'll go into week 4.
Okay, sir.
And if I can get an extra session, I'll take that.
Okay.
Okay, thanks.
Thank you.
Bye.
Okay, sir. Good night.
Thank you.
We are
Yes,
getting,
sir.
you're understanding, no?
Yes,
Yes,
sir.
sir. Yes, sir.